All right, hi everyone. Let's get right into chatting about Harvard CS50 Week 3 algorithms. So first things first, here in the CS50 website, we see that we have the video as always, a great video. And then down here we have our different assignments for Week 3. So if we take a look at the first assignment, that's going to be Lab 3 sort. Excuse me. So basically, the background for this lab is that we want to think about the different sorting techniques we learned in this week 3 video lecture and think about if we actually see examples of different sort methods used to sort different data sets, then can we backtrack and figure out which sorting method is being used? So let's take a little bit of a look into that. So these instructions are just basically walking through what the different data sets look like that are going to be sorted. And we want to store our reflections in a file called answers.txt. So answers.txt is going to have all our different reflections on why we think a certain sorting method used in a certain situation. So let's go ahead and go over to our code space. So basically, the first thing that we want to do is run the different, the different random sets, whether it's like random 5,000, random 10,000, and we want to run those and see how much time it takes to sort those using the 3 different methods. So when I ended up sorting them for the sort method 1, I ended up getting these values here for my sort time. And then if I scroll down, I can show the different values I got for sort method 2 and then for sort method 3. So basically, after thinking about it, I ended up concluding that sort method 1 uses bubble, but I want to explain why exactly I thought that. So bubble sort, as I say here, is the slowest of the 3 sort types we've discussed. And even though it has the same technically it has the same omega value for its upper bound, like n squared, its actual upper bound is n squared minus 2n plus 1. So yeah, this is generalized to n squared, but it's actually going to be, in essence, pretty much double the upper bound of selection sort, which is n squared divided by 2 plus n over 2, which we can generalize as n squared divided by 2. What this means is that, at least the way I thought about it, I would expect that bubble sort is generally going to take double the time that selection sort will take. And then we ended up seeing that a little bit. So for example, for the sort of one of the large ones, like random 10,000, that was 0.34 seconds for sort 1. And then for random 10,000 for this one down here, which I ended up, by process of elimination thinking is selection sort, is not quite half the time as 0.36, but still definitely lower. And there were others that seemed to be about half the time for that third one. And one other thing that made me think that was true is that we learned in lecture that merge sort is by far the fastest of the 3 sort types. And again, we have the 3 that we looked at are bubble, merge, and selection sort. And all across the board, this sort 2 method ended up being just quick for all of them. So I ended up thinking, okay, I'm pretty sure sort 2 is merge. And then, yes, so by process of elimination, sort 3 selection sort. So that was my thought about lab 3. We can go ahead and head back over to the specification and see what's up for the next part of week 3, which is problem set 3. So we have a few options. We do need to submit plurality, and then we can submit either runoff or tideman. And I actually think it would be good for me to go back and do tideman. So I did runoff. If any of you would like me to walk through tideman, just let me know. But I'm going to go ahead and talk about plurality, then runoff. So let's go ahead and go right into that. So for plurality, the whole setup here, and actually no, I'll go back to the specification. The whole setup here is all about inputting a specific number of voters and inputting, even before that, the candidates that we want people to vote on. And then each person is going to have one vote for one candidate. And then the program should output a winner. So here's some background getting started. There are a few things worth understanding, so I'm not going to walk through every single thing. But one thing that's definitely worth highlighting is that the file defines a struct called candidate, and each candidate has two fields. So they have a string called name and then an int called votes. So basically, each candidate structure is going to have its own unique name and its own unique number of votes, and these can both be changed. So that's really great for our purposes. The specification specifically says to complete the vote and print winner functions, and that we shouldn't modify anything else in plurality.c. So for the vote function, basically we want to account for if the name matches the name of one of the candidates that have been inputted by the user. But if the name doesn't match any of the names, then no vote totals should be changed. And then the vote function should return false to indicate an invalid ballot. And then we can assume that no candidates have the same name. Also, for the print winner function, the function should print out the name of the candidate who received the most votes. Basically, we just want to print the winner if there was someone who received the most vote. But if there is a tie, then the algorithm should output the names of each of the winning candidates on a separate line. So it should print out the results of the tie. And then here's some usage and further walkthrough. So let's go ahead and get into the code and check it out. So first things first, as always, we have our header files called up here. This max candidates is going to define the max candidate, so this can't be changed. And that's great because we don't want that to be something that can be changed later. Here's the definition of the struct that we looked at, which is the candidate struct. And then this is an array of candidates. So an array of the struct candidate, and it's called candidates. So that might be a little bit confusing, but we could call this anything. We could call this, banana. So we could say like candidate banana, and that would be an array of candidate structs called banana. But in this case, it's an array of candidate structs called candidates. And then there's going to be the number of indices of the array, or the number of elements in the array rather, is going to be equal to max candidates, which we saw equals 9. So all this is to say is that it's going to be an array of candidates where array 0 is one candidate, or array at index 1 is going to be another one, etc., all the way up to index 8, which is going to be the 9th candidate struct. And each of these is going to have its own name and votes, etc., etc. So hopefully that was a tad helpful. Here we have a integer declaration, so this is going to initialize candidate count as a variable. It's not going to initialize it to anything in particular, but that's okay. And then we have our function prototypes for vote and print winner. So those are the two functions we're going to update for this practice set. And then we have our main function. So as we see right here, we can see that there are going to be two sets of input. So the first set of input is going to be a single integer, and that's going to basically tell the program how many voters there are. And then we want to have an array of strings as the next like set of inputs, and that's going to be the names of the candidates. So for this first check, basically if there are less than 2 sets of inputs, then we want to print a error message that says, hey, this is how you actually use this setup. And then assuming that there are the proper, or not assuming, now that we know that if it's gotten to this stage, then there are the proper number of inputs, then what we can do is we can start populating the array of candidates. So we can start first by saying candidate count equals argc minus 1. And if the number of candidates inputted is greater than max candidates, which is 9, then we want to print an error message saying, hey, like we need to have a specific number of max candidates, which in our case, as I said, is 9. And then what's going to happen here is, now that we know if it's gotten to this step that there are a sufficient number of candidates, then we're going to populate the candidates array of candidate structs with each name and initialize the votes to 0. Then we have int voter count. That's going to be using a get int for the number of voters, and that's going to be a user input. And then what's going to happen here is the for loop is going to loop over the voters and then get the vote for each voter, and that's using get string. And then this is cool because it's basically going to call the vote function, and it's saying if the inputted string is not a valid vote, then it wants to print, we want to print an error message saying, hey, like this is an invalid vote. Basically what that means is that the inputted name is not identical to one of the names of the candidates inputted earlier. So we can keep going down. And this is the end of the main function. This is print winner, so it's basically going to call the print winner function, and it's a void function, so it doesn't take any inputs. But if there is a winner of the election, then it's going to print the name of the winner. And if there's a tie, it's going to print the names of all the tie people. Now we can go ahead and go to the vote function. So this is a bool function, so it's going to output either true or false, depending on specific conditions. So what's going to happen here is, since it takes as input a string, which we're calling name, and this is intended to be the name of one of the candidates, what's going to happen is vote is going to loop across the number of candidates, and it's going to use string compare to where it's going to compare name and candidate as at index I, their name, and if they're identical, then this is going to return a 0, or rather this string compare is going to return a 0. And then that means that this will be true if, oh, that's a little ugly. Yep, this will be true if name works. Meaning true if the name is actually a name of one of the candidates. And then if that's true, then we want to add a vote to that candidate. So that's going to be the same index of the candidates array. And then the plus plus, as we know, is just iterating by 1. And then it's going to return true, meaning, oh, that was a valid vote. But if it loops across the entire candidates, and then it finds that there's no matching name, then this bool function is going to return false. And then, like we saw earlier, if it returns false, then this is going to be the negation of whatever the vote value is. And if it's a negation of false, then it's going to equal true. And recall that if in an if conditional, if the condition is true, then whatever's in the if is going to be executed. So it's given that if the bool returns false, this is going to be true, and then it's going to print invalid vote. So that's right there. Now we can go to the print winner function. So as we mentioned, this is going to be a void function, so it's not going to take any input. And then what's going to happen first is we're going to initialize a winner tracker to 0. So this is something that I was thinking could be good just to keep track of. So like for instance, if we go down here, what's going to happen is, yeah, okay, cool. Yeah, what's going to happen is we're going to loop over each candidate, and then I wrote for each vote sum, we want to compare every candidate's vote score to every other candidate. And if any one candidate's vote score is greater than the initial value of winner tracker, then change winner tracker to that candidate score. So all this means basically is I started with winner tracker equals 0, and if anyone has more than 0 votes, then winner tracker should be updated to that person's vote count. But if any other candidate has more votes than that person, then the winner tracker should be updated to that person's vote count. That way we don't mess with any candidate's vote number, but we can keep track of basically the maximum vote count. And then down here, basically, now that we're going to have winner tracker done, we're going to loop over the candidates again and see which candidate's vote count is identical to winner tracker. And then whoever does that is going to win. And it might be that there is a tie, but this will account for that, no problem. Because if 2 people's votes count equals winner tracker, for instance, let's say that 2 people both have 5 votes, then this loop will actually print both their names, which is totally fine. And I wanted to put in this winner tracker checker conditional if candidates vote is greater than or equal to winner tracker, meaning that even if it's equal to someone else's, like there's a tie between them, then it will update. Like I actually don't need it to update. I could have just said greater than, but it just helped me conceptually to think through, okay, we want to be able to keep track of ties. Also, like usual, there's more elegant ways to do this than I did it, but I'm also happy to do it in a little bit more of a step-by-step way that is a little more explicit in what's happening. Also to teach it, because it's easier for me to walk through what's happening if it's just step-by-step like this. And yeah, we can go ahead and run Plurality and just make sure everything looks good. So cd Plurality, make Plurality, and then if we do Plurality, and then we just do Plurality, it'll let us know, hey, like that's not proper usage. And then we can do, okay, well, what if we have candidates like myself, and then we also have Darth Vader, and then we also have Yoda, a really good lineup, and then we have, let's say, 2 voters, and then 1 person votes for Vader, 1 person votes for Yoda. This is actually going to be a tie, so it's going to output Vader and Yoda, which is perfect. Let's say instead we do Hulk, Thor, Superman, and Batman, so like DC versus Marvel thing. Then we have 4 voters, 1 person votes for Superman, another person votes for Hulk, and then 2 people really think Thor should be whatever candidate this is. They're going to go for Thor. Excellent. And then we can go ahead and do check 50 just to make sure things are looking good. So, awesome. So we can see that everything returns good and we're all set to go. Excellent. So let's go ahead and move on to the next part of problem set 3, which is runoff. Or at least that's the one I'm going to look at. So like I said, there are a few different options. You can do runoff or tiedman. And again, if any of you would like me to go through tiedman, let me know. But runoff was kind of interesting to me, so I wanted to check it out. In Runoff, it's similar to Plurality in that we want to return the winner of an election, but we're going to give each voter the opportunity to show, or at least to tell us, like a ranked list of their preferences for candidates. So, for example, if there's 5 voters and there's 3 candidates, each voter is going to be able to rank their preference of candidates in order, and we're going to be able to return the winner of an election, even if there isn't a majority winner for the first go. So, for example, in this example laid out here, let's say that there are 9 voters, but if we look at each candidate's first ranked choice, then Charlie has 4 votes, but 4 is not a majority of 9, meaning like 4 is not greater than 50% of 9, which is 4.5. So what we want to do then is not just look at the top, but we want to incorporate people's other choices. So what we want to do after determining that Charlie's not going to be our first place winner is we want to eliminate the person who has the greatest number of lowest preference votes. And interestingly, that's actually going to be Charlie. So we're just going to go ahead and eliminate Charlie as if Charlie is not in the vote anymore. And then what we're going to do is we're going to take each person's next top ranking preference. So once these people are going to have Alice, these people are going to have Bob, and then these people down here are going to have either Alice or Bob. And then if we take the highest number of votes of a candidate in this next rank, we're going to have Bob, Alice, Bob, Bob. All that to say, Bob's going to get 5, Alice is going to get 4, and since 5 is a majority of 9, Bob wins. So that's how a runoff election is going to work in our scheme. And we just want to be able to create an algorithm that will actually do that for us. So the specification outlines specific things that need to happen on our end to do that. So we need to complete the vote function, the tabulate, print winner, find min, is tie, and eliminate functions. So I'm going to go ahead and walk through what I did personally, and let's jump right into it. So as usual, we have our header functions, and then below those we have some definitions for integers. So we have max voters and max candidates. This is good because we don't really want to simulate an election with 1 million voters, or like in the US there's like 300 million people. We don't want hundreds of millions of people in our algorithm. We just want a modest number, so we have 109. And then we're going to go down here. This is pretty important. This is basically a 2-dimensional array of preferences where in the notation preferences I, J, this is going to hold the jth preference for voter I of a candidate. So like, yeah, so basically what's happening here is, let's say we input preferences I, J. Well, that's going to return the index of a candidate So that's going to return the index of a candidate where that candidate is the jth preference for voter I. So for example, let's say one of the candidates is Hulk, like we saw last time. And let's say voter I, let's say voter 0, so the first voter, thinks Hulk would be a fantastic president or whatever this vote's going to determine, then that means that voter 0 is going to rank Hulk as their jth preference or their 0th preference for this election. And in this scheme, the lower the preference, the higher the preference. Or I mean, that doesn't make sense. What I mean is like the lower index of the preference refers to the higher preference. Like, let's say that there are instead let's say that there are instead 10 candidates and voter 0 is like, okay, Hulk would be a horrible president. Well, then they're going to rank Hulk as their 9th preference. Really their 10th preference, but in the array where 0 is the first index, it's going to be index 9. So this is just going to return the index of Hulk. So let's go ahead and continue along. Here we have a definition of a struct where this is going to be a struct called candidate, just as we saw with plurality, except this time instead of just having a string called name and votes as an int, we're going to have a bool value called eliminated, and that's going to be really useful for us for keeping track of who is still in the runoff. As before, we're going to have an array of candidates called candidate, and that's going to hold a bunch of values, and that's going to hold all the candidates, which is great. We have our voter count and candidate count, excellent, and then we have our function prototypes, and these are all going to be defined by us below. So here is the main function from the CS50 staff, so we're not really going to touch this. But yeah, there are a few things happening here worth noting. So first, we're going to check for invalid usage. Then we're going to populate the array of candidates. And then this is all pretty similar to plurality. One thing that's going to happen is we want to, while true, we want to tabulate the votes. And so while true, this might seem a little weird because technically a while function is going to continue as long as the condition inside of it is true. So if we just say while true, that's basically like a forever loop where it's just going to continue nonstop. But we do have a break. So if there is a winner, then we're going to go ahead and break the while loop. But that's just something worth noting right there. So we're going to call the tabulate function. We're also going to call the print winner function. Some other things are we're going to call the find min and is tie functions. So if there is a tie, we want to print out the names of the candidates who tie. Excellent. And then we also want to call the eliminate function if anyone with a minimum number of votes is still in the race. And then, yeah, reset the candidate vote count to 0. Let's go ahead and go right to our functions that we need to describe and implement for this assignment. So going to the vote function first, the vote function takes a few inputs, like it takes 2 integers and a string. So what we want to do first is loop across the candidates and determine if the vote is valid. And this is very similar to the plurality vote function, where here we're going to do a string compare and determine if the name inputted is identical to one of the candidate names. And if it is, then what we want to do too is we want to store the preference where the index of the voter is determined by the inputted integer voter, and then the jth preference or rank is determined by the rank inputted, and then I is going to be the index of the candidate, and that's exactly what we were saying earlier. And that's perfect. So that's vote. Tabulate is pretty chill, but one really interesting thing is this setup right here. So I'll go ahead and start from the beginning though. So what tabulate's doing is it's counting up the votes for all non-eliminated candidates. So first things first, we're going to loop across all voters and then loop across all the candidates. And basically this if is going to do all our important work for us. So it's going to see whether a candidate has been eliminated or not, and if they haven't, then it's going to add a vote to their vote tally. But the crucial thing is that we actually only want to calculate votes of each voter's top ranking preference candidate that is still in the race, meaning that they haven't been eliminated. If we just loop across all the voters and all the candidates and add a vote to every candidate who hasn't been eliminated, then we're going to have a bunch of candidates with a bunch more votes than they should have. So to account for that, we actually want to call the preferences array, where we want to use preferences at I and j to get the index of the candidate where that candidate is voter I's top ranking preference. So basically, again, even though this looks a little bit weird potentially, all this mess in here is going to return a integer, which is the index of voter I's top ranking candidate. And if they haven't been eliminated, then we want to add a vote to that person's tally. And then we want to break this loop, because if we keep going, then we'll basically add a vote to the voter I's next top ranking candidate. And we don't want to do that. We just want to get one for the top ranking candidate that's still in the race. Let me see. Yeah, no, that's pretty good. Okay, cool. So let's go ahead and keep going. And I actually wanted to keep this comment here because this was attempt 1. It took me a second to really get the simplicity of preferences IJ being used, but we can see that I ended up going through this one that took some time to think through, but this was not the best solution that I commented out. But I wanted to keep it just to illustrate, like, it can take some time, and you might end up going down a rabbit trail of thinking, oh, this solution is going to work, and it doesn't quite work, and that's totally normal. Some iteration is going to help with that. Awesome, so let's continue with the print winner function. So what's going to happen, as we've seen a lot, is we're going to loop over the candidates. And basically, if a candidate's total number of votes at this point is the majority, meaning that it's greater than voter count divided by 2, then we want to print that candidate's name and return true. So what's cool about this is that if this condition holds, then there isn't going to be a tie, because two people can't simultaneously have a majority. So that's just going to work. And if one person has a majority, it's going to return true. Otherwise, it's going to return false. And if there is no winner majority-wise, then what we want to do is go through the runoff process. First, find the minimum, meaning that the minimum person has the lowest number of votes remaining, and they haven't been eliminated. So we're going to loop through the candidates, and if a candidate hasn't been eliminated and their votes are less than the minimum, then we're going to set the minimum to that person's votes, and we're just going to continue to do that as we run through all the non-eliminated candidates. So I set the minimum to voter count initially. That way, let's say there's like 100 voters, which is the max, then the minimum has to be less than 100. So it'll just continue decreasing until we get to the true minimum. And then it'll return minimum as an integer. And then we can keep going down here. Let me see. Yep, that was minimum. Okay, and then this is the tie function. So if it's a tie, we want to return that it is a tie. Otherwise, we want to return that it's not a tie. So let me see. Let me go down here. So I have a tie counter that's going to keep track of anyone that has the same score as another person, or at least, no, anyone that has the same score as minimum. So we're going to loop over candidates, and then if a candidate hasn't been eliminated, then the remaining candidate counter is iterated by 1. If the candidate's votes equals the minimum, then tie counter is iterated by 1. And then down here, the reason for that setup is basically this if conditional is going to check whether the remaining candidate counter equals tie counter. And if it does, then it's going to return true, else it's going to return false. So I think that does a good job of successfully incorporating what we need to do for that. All right, finally, the eliminate function is going to eliminate the candidate or candidates in last place. So anyone whose votes equals minimum, they are going to get eliminated, meaning that we're going to change their eliminated value to true, which remember is a bool value in the struct called candidates. And then once we finish that, we're just going to go ahead and return. So this is a void function, so it's not actually going to return any output specifically. We're just going to go back to the rest of the main function. But yeah, that's everything actually for runoff. I'll go ahead and just make sure it's looking good by running some examples. So let me go ahead and clear the terminal a little bit. Okay, so cd runoff, make runoff. Let's run some examples. So like, let's go back to the Hulk, Thor, Superman, Batman example. Number of voters, let's just say 3. So voter 1, let's say their ranks are Hulk, Thor, Batman, Superman. And then the next rank are Superman, Thor, Batman, Hulk. And then let's go Thor, Batman, Hulk, Superman. Let's see who's going to be the winner here. Okay, so we actually have a 3-way tie. And that kind of makes sense because the votes were kind of distributed all over the place and there weren't that many voters. So the only person who is not in the tie is going to be Batman, unfortunately. Sorry, Batman. But let's go ahead and just make sure that it meets all the other requirements. So we'll go ahead and do check 50. And then once this runs, it'll let us know what's up. I'll go ahead and scoot this up a little bit. Okay, yeah, and there's a few things happening right here, but everything looks good. I will say the function that took me the longest to get right was definitely tabulate. All the rest made sense. But tabulate took some time, but thankfully, yep, got it working, and everything runs good. So yeah, thanks so much for watching this video. I hope it was helpful. Feel free to stop by again. I'll be doing the next one soon. All right, take care. Thanks.